All right, very quickly, let's jump into part 2, covering slides 19 to 22. We're looking at dummy variables for multiple categories. We always drop one. We will then look at interactions involving dummy variables. So, well, when we use dummy variables for multiple categories, we define membership in each category by a dummy variable. So suppose we have 4 groups: married men, married women, single men, and single women. These are our 4 groups, and we are interested to compare single male to the other 3 groups. Then what we will do is we'll keep single male as the base group, so we'll drop that one. But in our econometric model, we will include 3 dummy variables: married men, taking a 1 if married, 0 otherwise; married females, taking a 1 if married and female, 0 otherwise; single female, taking a 1 if single woman, or 0 otherwise. See, so the category that did not make it into the econometric model is single men, and we are holding that out as the base group that we will compare single men to all the other groups. So the principle here is that if you have multiple categories, then you're going to have, let's say you have G groups or G categories, you're going to have G minus 1 dummy variables in your econometric model, leaving that one dummy variable out that you will use as the base group. Okay, if you do not do it that way, you will fall in the dummy variable trap. Now, what if you have a lot of categories? Well, you could group some of the categories together, right? Here is an example. We have credit rating from 0 to 4. So that is rating 0, 1, 2, 3, 4. That's 1, 2, 3, 4, 5 groups. And so there are 5 categories here, and we will drop one so that we hold on to into them. We keep in the model rating 1, 2, 3, 4 and drop rating the worst 0, right? So we will compare the worst to all the others. The worst will be the base category. So for example, if we are going to interpret delta 1 here, we'll say that holding other factors constant for if credit rating 1 compared to the worst, then municipal bond rates changed by delta 1 on average. We can have interactions involving dummy variables and a non-dummy variable, right? So before I jump into what these all mean, let's work on this example here. We have the econometric model involving log of wage as the response, female, education, and then we have the interaction term female times education here, and the dummy delta 1 on them. Well, the dummy female, right? We have our dummy variable female up here, and then we interacted that dummy variable with education. This is what I mean, pardon me. We have the dummy variable female, and we interact our dummy female variable with education, which is continuous. Okay, so from here, we can derive our male wage equation where, wherever we see female, it took a 1 if a woman, or a 0 otherwise. And so for the male wage equation, we have beta 0 plus delta 0 times 0, right, plus beta 1 education delta 1. Female gets a 0 times education plus u, and we get this male wage equation, log of wage equals beta 0 plus beta 1 education plus u. Okay, what about the female wage equation? Well, female equal 1 if woman, so our log wage will equal beta 0 plus delta 1 times 1 plus beta 1 times education plus delta 1 times 1 times education plus u. So at the end of the day, we have beta 0 plus delta 0 as our intercept for the female equation, and beta 1 plus delta 1 as the slope for the female wage equation. Now, if you compare that to the male wage equation, which only has beta 0 as the intercept and beta 1 as the slope, you can see, well, if delta 0 is 0, then the male and female wage equations will be equal in intercept. Now, if delta 1 is 0, then in slopes, the male and female wage equations will be the same. But we can test this, right? We can test it. We can do a hypothesis test for this. So say we want to test whether the return to education is the same for men and women. What we are trying to test here is the slopes. Are the slopes the same in the male and female wage equations? So our null hypothesis will have, well, delta 1 is 0, and the alternative will say delta 1 was not equal to 0. You see, and the test will be a t-test that we will do. Now, if we wanted to test whether the whole wage equation for males and for females, or for men and women, were the same, then, well, in that case, we are looking to see if the intercept and the slopes in the two equations, the one for males and the one for females, were the same. So in that case, well, in the null hypothesis, it will be delta 1 is 0 and delta 1 is 0 and delta 0 is 0 in the null hypothesis, and in the alternative, we will say both not 0. And in this case, we'll do an F-test. An F-test where we compare the full model to a restricted model. Now, can we visualize all of this in a graph? Yes, we can. I am going to leave that part for us to work on, but for those in the YouTube streets, what I mean by that is delta 1 can be positive or negative, and delta 0 can also be positive or negative. Now that gives us a combination. When you combine these two, it gives us about 4 cases. And so what are those 4 cases? The 4 cases here are 1, delta 0 is positive, delta 1 is positive, right? Case 2, delta 0 is positive, delta 1, you guessed it, negative. Case 3, whoops, I meant to write 3. Case 3, delta 0 was negative and delta 1 was negative, or is negative. Case 4, delta 0 negative and delta 1 positive. You see, now these will give us some 4 graphs. Now, if delta 0 was negative, what does that mean? Let's go back. If delta 0 is negative, what does that mean? It means that the intercept for women, right, beta 0 plus delta 0, is less than the one for men. And if delta 1 was negative, if delta 1 is negative, this delta 1 is negative, then it meant that the slope for women was flatter than the slope for men. So let me write that down in case people were interested to draw these out on their own. I'll draw one, and then I'll leave the rest for those on the YouTube streets to do. The remaining will be done in my class sometime week 7 or week 6. Okay, so let's let me write that out. What do I mean by delta 0 is negative? Well, the male intercept is beta 0, and the female intercept is beta 0. I'm getting my stuff from right here. Beta 0 plus delta 0. And so if delta 0 is negative, then the intercept for women is less than the intercept for men. Now, you saw that earlier on, right? You saw that earlier on, something similar to, it will look like this. The female intercept is below the one for the male, is below the male intercept. Now, we also have information in this part. The only difference between the part 1 and part 2 is we have some additional information here about slopes. So the male slope, let's use a different color. The male slope is beta 1. The female slope is beta 1 plus delta 1. You see, so if delta 1 is negative, then that meant that the slope for women is flatter than slope for men. And so let me draw just one. One where delta 0 is negative and delta 1 is negative, right? So which one am I drawing? I'm drawing this one, item 3. So item 3, we will draw delta 0, negative, delta 1, negative, and I'll draw my axes so people can know what we are doing and go try it out on their own. We have log wage, and we have here education. Okay, so delta 0 is negative, delta 1 is negative. What did we say about the intercept? If delta 0 is negative, the intercept for females is less than the one for males. So for females, I'll use red. For females, the intercept will be down here. And for males, I'll use blue. The intercept will be up here. All right, we are done with the intercept. And now the slope. The male slope is beta 1. The female slope is beta 1 plus delta 1. If delta 1 is negative, the slope for females is flatter than the slope for males. The slope for females is flatter than the slope for males. So I'll draw the female slope first, make it flat, so something like this, right? And then I'll draw the male slope, make it so that the female slope is flatter than it, and so the male slope will be like this. And so here, men, and red, women. Now, the question is, can you do the others? I hope you can. All right, I will stop the video here, and for my class, we'll do more of this in class during an assignment. And for everybody else, thank you for stopping by. Like, share, subscribe, hype. Have a good Sunday. Dr. T is